Hello everyone, welcome back to another video for the series. I'm Inokiyu and today I brought another exciting problem from IMO, and this problem was particularly interesting because it really stressed the if and only if condition in functional equations. And so for this problem, I'm going to share my personal solution to this problem and then share the official one because my solution was not complete. So even though my answers were correct, it's not complete. So I think I'll only get like 3 or 4 points because I was not able to prove like the only if condition, if and only if condition. So first of all, noticing this problem, what I did is I just did I just did really typical thing like substitute 1. So you have f of 1 squared 2 times f of 1 squared plus 2 times f of 1 equals 1. So we know that f of 1 squared equals f of 1. Therefore, f of 1 equals 1. That's what we know. And then I did when because we know that this is true, I substituted 2, 1, 2, 1. So we have f of 2 squared plus 1 over f of 2 squared plus 1 equals 1 because did the same thing. Therefore, notice that f of 2 squared is equal to f of 2 squared. Now, this form quite intrigued me a lot because just think of it like this. You're going to substitute an unknown variable n. Then we have, and then like n1, n1, like that. Then we have equals 1. Therefore, f of n squared is equal to f of n squared. F of n squared is equal to f of n squared. Oh, that's interesting. F of n squared is equal to f of n squared. So this is what we know, and yes, this is what we know. And then the next thing that I did is I noticed that there may be a different solution. Yes. And there arose because I think yes. So I substituted 4 1 2 2 4 1 2 2 because that's the next thing that we can try, like splitting them. So I got f of 4 squared over 2f of 4 is equal to 4 1 2 2, and the reason why I always try 4 1 2 2 is to not get 1 here. So we have 4 1 that's 17, 2 2 that is 8. So we have 34 f of 4 is equal to 8 f of 4 squared. Now f of 4 is equal to, wait, I think I made a mistake. 4 1 2 2. This is right. Okay. Because this is not the form that I was expecting. No, I'm pretty sure I made a mistake here somewhere. This is not the form that I was looking for. This is not the one that I got when I solved this earlier. 4 1 2 2. I forgot 1. That's fine. Then cross multiplying, we get 34 f of 4 is equal to 8 f of 4 squared plus 8. So we have f of 4 squared minus 17 f of 4 plus 4 equals 0. And I was like, oh, nice. Okay. 4 f of 4 minus 1 minus 4 17 equals 0. Therefore f of 4 what equals 1 over 4 and 4. So what? We have 1 over 4 and 4. So I was like, 4, 4, 4, this is quite interesting. What if our solution is f of x equals x and f of x equals 1 over x? Because these are both positive, always, with our domain here. And I substitute if this is correct. And this indeed satisfies this first equation. Like just when f of x equals x, this equation is true. Yeah. And then when we also substitute this one, we know that it is also true because just I will just demonstrate it here. Plus 1 over x squared over 1 over y squared plus 1 over z squared. Just multiply w squared, x squared, y squared, z squared on top and the bottom because they're equal to each other. We have this lovely condition right here. And yeah, we get our same thing. So we proved that these two are our solution. But then I was stuck here because I was not able to prove that these are the only solutions. And they are indeed the only solution, but if I finish my solution like this, then I will not get a full credit because I was not able to complete it. So, new approach. Approach. First of all, what we can do here is substitute a, b, 1, no, sorry. What I can do is substitute root a, root b, 1, and root ab to x, y, w, x, y, z. So we know that a plus b over, 1 plus, what am I doing? It's f of a plus f of b over 1 plus f of ab is equal to a plus b over 1 plus ab. This is always true. Yeah. So from here, we are going to deduce more information about f of x wait. Oh, sorry, it's not this one. I actually studied this problem yesterday, so my memory slipped. Sorry. Yeah, this is right. So we have f of x plus f of x over 1 plus f of x squared. That's the same thing as this one, we proved it. this equals x plus x over 1 plus x squared. Okay, so we have 2x plus 2x f of x squared equals 2f of x plus 2x squared f of x. Organizing them, we have minus 2, 1 plus x squared f of x plus 2x equals 0. So I think we can vector them. Let me cheat because we know that these are the solutions. Minus 1 over 8. Oh, yeah, is this right? Just divide 2 on both sides. Oh, we actually need to do it like this. That way, we get everything. Yeah, so therefore, or f of x equals 1 over x. Now, if it was, so if I, yes, so I think if I was the one who is solving this problem, I would have stopped here and then not get full credit, because I didn't know that we also need to consider the case when f of x is like a piecewise function. So it looks something like wait, how do I do it? So it looks something like this. It, it might look something like this because we never know. It's f of x equals x or f of x equals 1 over x. So it may satisfy both conditions at the same time. So for x in like some interval is true for this, so we get this equals 0. But for the other interval, we get this, so this equals 0. So that might be true. So we need to prove that that is not true. So we don't have a piecewise function. So I will explain more to this because I was also confused here. But let's prove that this is our only solution first. So for f of a equals f of b, a and f of b equals 1 over b. Let f of b not equal b and f of we're actually going to use contradiction here. For the sake contradiction, let f of a not equal a and f of b not equal 1 over b. For some a and b. Now notice that if f of a is not equal to a, then f of a must be 1 over a, because f of x must be x or 1 over x. Yeah, so we're going to do a clever substitution here. We're going to substitute a comma root b comma 1 root ab. So we get, let's just substitute it first to see what we get. F of b over 1 plus f of ab is equal to a plus b and ab. No, 1 plus ab. So, Wait, yeah. Eh? Mm, this is. I don't think this is the right substitution. I think. I'm sorry. I think was. Uh. Mm, I remember the solution forcing it to somehow have f of a equals a. Okay, then let's think of it like this. Um, then notice that if f of a is not equal to a, f of a must be 1 over a because of our condition right here. We cannot have f of a that's neither a or 1 over a. So we have this true and plus b, because if it's not 1 over b, if it's not 1 over b, it must be b equals a plus b. Let's rearrange them. So recasting, we have, this is quite mean. B squared. Anyways, a plus b equals 1 plus f of ab. So we have f of ab equals 1 over a. What is this? Yeah, oh, it's b. So 1 over a minus ab, so we can cancel 1 plus ab squared minus a over a plus b. This looks really messy right now. Let's reorganize this. This list. Wait, I really don't like how we have minus a here. I think it should be something different. Please let me know if I made any calculation mistake. One over a plus b. I think I did it correctly. 1 over a b ab squared plus 1 minus 1. I didn't make any mistake till now. Okay. Okay then. We somehow. Oh, for some a and b not equal to 1. We somehow need to force that a and b equals 1. That way we get a contradiction. And the reason why they're not equal to 1 is because if they're equal to 1, then we cannot make it into this form right here. And what is f of ab? What's f of ab? Ah! Ah, no, sorry. Wait, I forgot how to continue from here. No, no, let's do it slowly again from here. Um, this is right. Mm, 1 plus AB. 1 plus AB. Now, AB is an integer here. What? I'm sorry. Okay then. I will not try to remember something new, but just continue on my own because, yes. Um, how do we get a contradiction here? We somehow need to prove that f of a equals, a equals b equals 1. That's the only way they can get a contradiction. So that f of 1 equals 1. Wait, can we compute the value of f of 1 here? No, we can't. No, what do you mean? We actually can. I just did it here. So f of 1 equals 1. Yeah, f of 1 equals 1. And notice that this equation does satisfy when a equals b equals 1. But that's not cool here. So let's somehow prove that this is the only solution. How about we try because I remember it was in like some kind of vector form. Mm, this 1 over a is really disturbing, so let's multiply both sides by ab. I mean, not both sides, but like top and bottom with ab. Mm, can we somehow, we have ab? No. So this combo doesn't work. Oh, then we have 6 cases. That's right, that's quite a lot. Um, mm, oh, wait, I think. Yeah, how do we prove that the case when a equals 1 equals b is the only solution? Let's just do it one last time. Instead of substituting root a root b, 1 root ab, should we try a different thing because they might not be the one that we should substitute? No, but actually they are correct. Okay. Then let's try this slowly again. Um, first of all, first of all, f of ab equals ab. We have 1 over a plus b equals a plus b. Therefore, a equals 1. If a equals 1, can we find the value of b? You just get f of b equals b, right? Oh, but this contradicts with the fact that a is not equal to 1. So then we have, this is, I think this is different from the official solution. It didn't have this. Yeah, it kind of utilized this substitution, but I forgot how to continue from here. But yeah, so I think this also works because this is also a contradiction. Um, yeah, I hope this works because if not, then I'll be so sad. I need to find a new way. No, but I'm pretty sure it will work. So, because this is also the section that I struggled when I was trying to continue with my solution, like first half of this video. But okay, multiply AB on both sides so that we have b plus a squared b equals a plus b. Not both sides, but multiply AB here. We can cancel these two out, I believe, and therefore we have AB equals 1. So this contradicts also. Therefore, oh nice, it works. Yeah, okay, so yes, I'll slowly explain each steps again. So substituting this will lead to this equation, and at first I was like, what if there are other solutions, because we substituted this specific like I'll say quadruples, and like what if we have other ones when we substitute other quadruples. But that's not actually true, because what this is saying right now is if this, then this. So if our first one is true, then this is true. So if the one given is true, then this is true by our substitution. But if that is true, this is true. But like a statement cannot be sometimes true, it must be always true. Therefore, because this one and this one, they're if and only if condition, we have this one and this one as an if and only if condition. So this is true. So f of x equals x, or f of x equals 1 over x is true. So this is indeed true. Now let's talk about this proof. So for the sake of contradiction, let f of a not equal a and f of b equals not f of b not equal b for some a and b not equal to 1. And notice that by our this fact right here, we must have, if we substitute this one, then we must have f of a equals 1 over a and f of b equals b. Yes. Then continuing, we have this one right here. Yeah, so what this is saying right now is if this is true, then this is true. That's what it's saying. Then for this to be true, we need to check if this can be true. Wait, if this is true, then this is true. Yeah, so if A, then B. If not B, then not A. Yeah, so we just need to prove that this cannot be true. That way we prove so this is because if this, then this. So it is saying that because this condition right here is, sorry, so if this condition right here is if this, then this, that is the same thing as if not this, then not A. So it suffices to prove that if not this, so this is not true. It suffices to prove that this is not true. So, sorry, let's do that quickly. And let's check if this can be true. So all the possibilities for this case is when f of AB equals AB or f of AB equals 1 over AB by our statement right here. But if this is true, no, it cannot be true because it contradicts with our fact that A is not equal to 1 because they're if-then condition. Yeah. If this, then this. So first of all, this contradicts with the fact given provided by this. And this also contradicts with the fact that it's proven by this one, provided by this one. That means it is if A, then B, but A and B contradicts each other. So, so we wanted to prove if A, then B, but if A, then, so by our effect here, if A, so if this, then this is true. Sorry, I confused everyone with saying that if not B, then not A. We actually don't need to use that. We just need to use if A, then B. This is true because our effect that we use right here is true. But if A, then B is true, but if A, then B is not true because they contradict each other. That means it's if not A. So, no, sorry, we don't need to think about if not A. So if A, then B is true, but because if A, then it is not B, we have a whole contradiction. So this whole thing is not true. So A must not be true. So this is not true. That means for some A and B not equal to 1, there is no such case when f of A is not equal to A and f of B is not equal to B. So the opposite of that is, so something that is not f of A not equals A and f of B not equals 1 over B is it's either so it is, sorry, f of A not A, f of B not equals 1 over B. So this is not true. So only this is true because we know that we don't have this ones also. So because this and this are this one right here, we prove that they are the only solution. Oh, okay, so that was quite confusing with the logics right there, but yes. So I think this is the solution. Thank you so much for watching this video. Sorry about the confusion right here, but in the next video I'll try to make the solution as clean as possible. And thank you so much for watching this video and see you tomorrow. Bye.